So in the previous lesson here, we were looking at the integral of e to the x, which is e to the x. But in all of those, we were just doing indefinite integrals or antiderivatives. So here we just want to practice a little bit with definite integrals, okay? Definite integrals. So, for example, let me get rid of that, okay? Here we want the integral from 0 to 1 of e to the negative x. So we've got this region here, and I want this area, okay? Okay, so that's what we're trying to find, is that integral from 0 to 1. Okay?
Is there a break in the graph, or that's just like...
It's just a little typo. It'll mess up in the printing there. Okay, so let's think about this. What is the integral of e to the negative x? Negative e to the negative x, right? The u is negative x, du is negative dx, so I just need a negative there, which means I need a negative out here to get my e to the u du. Okay? So I have negative e to the negative x. Now we've got to evaluate that from 0 to 1. Okay? So if I plug in a 1, I have a negative e to the negative 1 minus a negative e to the 0. Okay? So that is negative 1 over e plus 1. Okay? So again, same rules that we had in our previous lesson. The only difference is that we're doing definite integrals now. Okay?
0.72. Oh, we don't have to go any further.
No, you don't have to go any further. In fact, you may see this on a no calculator part. Just leave it in terms of e. Even on the calculator part, you're welcome to leave your answers in terms of e, unless they told you to give your answer to a certain number of decimal places or something like that. Okay? All right, let's try this one. So I want the integral from 0 to 1 again. 0 to 1, so we're coming over here from the y-axis to there. How am I going to go about finding this integral? What's that? Okay, how are we getting that?
Because it's bottom, it's u prime over u.
Okay, this is u prime over u. This is the integral of u prime over u. Okay. So, again, just in case you're not seeing that, u is a 1 plus e to the x. Du is e to the x dx. All right? So, this right here is the du. Okay? I think I'm a little redundant here. Well, we'll leave it. Okay? So we have now the integral, if that's du, I have the integral of 1 over u, du. Yeah, I need to get rid of.
Wait, I thought we just said it was u prime.
That's why I said this is it's redundant, because I wrote the u prime and the du. It's,
Okay, I understand.
yeah, it's du over u, not u prime over u, and then another du. So I got a little bit redundant there, sorry. So if I'm doing the integral of 1 over u du, that is the ln of absolute value of u, okay? Now, when we do u substitution, remember we have one of two choices. You can either substitute the u back in at this point and keep the boundaries the way they were. The alternative is, since u is 1 plus e to the x, I could make the upper bound u equals 1 plus e to the first, and the lower bound u would equal 1 plus e to the 0, which is 2, okay? It really doesn't matter which one you choose to do. Since I've got this here, I'll go ahead and use the bounds that I just found, going from 2 to 1 plus e. Alright, so using our fundamental theorem of calculus, I've got the ln of 1 plus e, which is positive already, so I can get rid of the absolute value, minus the ln of 2, which I could then rewrite, since it's subtraction, ln of 1 plus e over 2.
Can we do like put 1 plus e to the x inside the ln and use 0 to 1?
Yes, we can. Yeah, that's the other way you could have done this. Ln absolute value of 1 plus e to the x, and then use 0 and 1. Either way, here we'd have ln of 1 plus e minus ln of 1 plus e to the 0, which that's the 2, ln of 1 plus e minus ln of 2, and you would get here as well.
Do we need to simplify it to the ln e plus 1 divided 2 during the exam?
I would go ahead and simplify that far. I think it'll be helpful in the future especially, but I don't know if AP would take off if you stopped here. So I would just go ahead and do it. Okay. One more, and then got some problems from the Barons for some practice. Okay. So we have the integral here from -1 to 0 of e to the x cosine of e to the x. -1 to 0. So what are you going to do to take the integral here? What?
So if u equals to e to the x power, the du of e equals to
Isn't that like x cosine?
Wait, hang on 1 second, I'm sorry.
the du of e the same.
Du is e to the x dx. Okay, so we have du right here, right?
What is that parenthesis?
They're just brackets. It's a way to distinguish between these parentheses and the other parentheses. They don't do anything special. Okay, so this is the integral from, well, I won't put from or to anything right now. This is going to be the integral of, these give us the du, and that's cosine of u. All right? What is the cosine, the integral of cosine? It's sine of u. Okay? Now again, we could convert our bounds. Not really going to save us much time in this case. So I'll go ahead and just plug in the e to the x. This is sine of e to the x evaluated from -1 to 0. Okay? So this is going to be sine of e to the 0. Sine of e to the 0 is sine of 1 minus the sine of e to the -1, so 1 over e. Okay? Make sure that our calculators are in radians, as they should always be for calculus. And then we can get our answer. So we get -1.593 or 15929. Can always give extra decimals, and that's fine. Okay? All right. So let's yeah, we don't have enough time to do these together, but there's some practice multiple choice problems you can try on your own. All right, and all right, so you got point. Yeah, that doesn't make sense, does it? That doesn't make sense at all.
0.4818.
0.4818. There we go. That looks a lot better. Those go on here as well. There's some Barron's problems that you can practice with as well. That'll be good to do. Okay? So.